Quadratic word problems. Look at this. The daily high temperature in Death Valley, California in 2003 can be modeled by this equation. Wow. Where T is the temperature in degrees Fahrenheit and D is the day of the year. What was the maximum temperature in 2003 to the nearest degree? Now, hey, listen. Maximum, minimum happens at the vertex. So a lot of these questions, you're just finding the vertex. This is in standard form. And in standard form, the vertex formula, first you find your x of the vertex, which is opposite of b over 2a. And then you substitute that number into the equation and you solve for y. So if you look here, our b is that 0.657 over 2a. The a is in front of the d squared in this case. So that would be the negative 0.0018. All right. Get your handy-dandy calculator. So up top we'd have negative 0.657. Denominator will have negative 0.18 times 2 is 36, so 0036. Now here you got a negative divided by a negative. You know that's going to be positive, so you don't even need to put in the negatives in your calculator. 0.657 divided by 0.0036, 182.5. Now that is the x-coordinate of our vertex. In this case, they didn't use x and y, but over here, the t of d would be like our y, and then the d's would be like our x, and d represents the days. So the x is our day, and then the y would be the temperature on that day. So we know the highest temperature is going to happen on day 182.5. Now what is that temperature? I don't know. We'll figure it out. So this is where we substitute in. So we're going to have T of 182.5 equals, and every time we see a D in the equation, we're putting in 182.5. So we have negative 0.0018 times 182.5 squared plus 0.657 times 182.5. And then we have the plus 50.95. Now, what's rad about my calculator, not to brag too hard, I could put it in just like this, and it'll just give me the answer. Otherwise, you could do it in chunks, but do remember your order of operations. When you're doing this first part, you have to do the exponents first before you do the multiplication. So let's see. Negative 0.0018 times 182.5 squared. Negative 59.95-ish. I'm rounding there. And again, you could probably do this all in one step on your calc. I'm just doing this in case your calculator doesn't do all this. You could see like each part. Let's see, 0.657 times 182.5 is 119.90. Now, I rounded. If you're doing exactly this in your calculator, it might be slightly different than mine. Let's see, negative 59.95 plus 119.90 plus 50.95. I got 110.9, but it said to round to the nearest degree, so that would be 111 degrees Fahrenheit. Wow, that's pretty steamy. And that happened on the 182nd and a half day. The function a of x equals negative x times x minus 10 describes the area A of a rectangular flower garden, where x is its width in yards. What is the maximum area of the garden? Now remember, if this was graphed, if this was a parabola, this is in intercept form. So it gives you the zeros. On the outside, it's just x, which means 0. The other one, it says x minus 10, so that means it's also going to intercept at 10. Other thing I notice is a out in front is negative, meaning this would be an upside down parabola if it was graphed. Now it says, where is it the maximum area? What is the maximum area? So that's going to happen at the vertex. Now if this is 0 and this is 10, the vertex is always right in the middle of those intercepts. So right in the middle of 0 and 10 would be 5. That's our x. We can just substitute it in now. A of 5, and every time we see x, we're going to substitute in a 5. So we'll have negative 5 times 5 minus 10. That becomes negative 5 times negative 5, which is positive 25. So remember, the x was our width, and the y was the area. So if the width was 5, the area will be 25. Let's see. What is the maximum area? 25, and what were we talking about? Yards? Yards. 25 square yards. Baby! All right. Look at that. A bald eagle snatches a fish from a lake and flies to an altitude of 256 feet. The fish manages to squirm free and falls back down into the lake. Its height, h in feet, can be modeled by h of t equals 256 minus 16t squared, where t is the time in seconds. How many seconds will the fish fall before hitting the water? Whew. I think we should factor that. Now, here's something I know. 16 is a common factor there. So if we were to factor out a 16, 16 times 16 is 256, and 16 times t squared is 16t squared. And look at that. Those are also both perfect squares. So we have a difference of squares. Square root of 16 is 4. Square root of t squared is t, so we'll have 4 plus t times 4 minus t. Cool. That's about all we can do there. Let's see what else it's asking. How many seconds will the fish fall before hitting the water? We know the height that we want. Hitting the water would be 0. So we're solving the equation 0 equals 16 times this. Great. Now, you could divide by the 16, blah, blah, blah. It wouldn't make a difference. 0 divided by 16. You could almost ignore the 16 on the outside. But here, if we're solving for t, 4 plus t equals 0, and 4 minus t equals 0. Here, if you subtract the 4, you get t equals negative 4. Now, is it going to be negative 4 seconds before that fish hits the ground? No. That's an unrealistic solution. It's out. Here, you could add the t to the other side, and you'd get 4 equals t. Positive 4 seconds? Is that a realistic number? Sure. So, 4 seconds until that fish falls. Good job, fish. He survives another day. He does have some talon holes in his back, though. Poor guy. A soccer ball is kicked from ground level with an initial vertical velocity of 32 feet per second. After how many seconds will the ball hit the ground? Use the general projectile function above. I put it below here for space, but on your sheet it's above. So h of t, they always have negative 16 in front of the t squared. T is time, and then it's plus your velocity times time, and then plus your h sub 0. That's your starting height. So we're looking for when this ball hits the ground again. The ground is at 0 feet. So for the h of t, I'm going to put 0. Equals negative 16 t squared plus, here's where our velocity comes in, and it was 32 feet per second. So 32t plus the starting height. Now, he's kicking it from ground level, so plus 0. We don't even need that plus 0, so we can get rid of that. Now, if we're looking to factor this, anytime my first term is negative, I factor out a negative. I know that 16 goes into both of them, and I know that they both have a t. Negative 16t times t would give us the negative 16t squared. And then negative 16t times negative 2 would give you the positive 32t. So this will give us two answers for the time. This t on the outside would equal 0. This t over here, t minus 2, would be positive 2. Now, again, this is time in seconds. So they're saying at 0 seconds, the ball's on the ground. Duh, that's when we're kicking it. And also, it's going to hit the ground again at 2 seconds. So that's the answer we want, right? 0 seconds is right when we kick it. We're trying to see how long it's in the air. So it's in the air for 2 seconds total. Let's see. A football is kicked from ground level with an initial vertical velocity of 48 feet. How long is the ball in the air? Same formula, very similar problem. So we're waiting until it hits the ground again. So the height is 0 equals negative 16t squared. That's just built into the formula. Plus the velocity, which is 48 times t. And again, plus the starting height, but it did say we're kicking it from ground level, so it would say plus 0 back there, so we'll just ignore it. And again, we can factor out a negative 16t here, because negative 16 goes into 48. So negative 16t times t is negative 16t squared. Negative 16t times negative 3 would give us the positive 48t. We'll get our two solutions. The t on the outside would be 0. Again, that's not what we're looking for, because that's 0 seconds. That's when we're kicking the ball. The other one, t minus 3, t equals positive 3 seconds. That's the answer we're looking for. The ball's in the air for 3 seconds. The height of an arrow in feet is modeled by this equation. Ooh, where t is the time in seconds since the arrow was shot. How long is the arrow in the air? Now, if you look, they filled in part of the formula. Let's pretend like they didn't. Remember, the 63 is our velocity. So they'd be like, it went with an upward velocity of 63 feet. The number back here was always our starting height. So we're starting shooting this arrow from 4 feet, which makes sense. It's like shoulder height. You're like, ah! Great. So they're not always going to set them up for us. All right. So we're seeing when it hits the ground, 0. Now I'm looking here, and I see my first term is negative, so I have to factor out a negative. There's no other common factor. So that'll change it to positive 16t squared, negative 63t, and then negative 4. Now that's a pretty brutal combo. We have to factor that, so we're going to multiply first and last. 16 times negative 4 is negative 64. We need the factors to be 64 apart from each other. Or sorry, they have to multiply to 64 and be 63 apart from each other. It's going to be 1 in 64. So to make them add up to negative 63, it'd be negative 64, positive 1. But remember, when you're factoring and you have those numbers in front of the t squared, we have to try to divide them by that number. So this we could do. It's just 4. This one you can't. So you would bring the 16 to the front if you were writing it in proper factored form. But we care about the answers. It says t minus 4. That means t equals positive 4 seconds. Does that make sense? Sure. So that's a good answer. Now this one, if you look before we moved the 16 to the front, we're looking for the solution. So it was plus 1/16. That means t would equal negative 1/16 if we solved that problem. Does that make sense? That the arrow was on the ground in negative 1/16 second? No, we're not talking negative time. Get out of here. Get out of here, man. It's 4 seconds. Wow. I think this is the last one. Oh, we got 2 more. Phew. A juggler throws a ball in the air from a height of 5 feet with an initial vertical velocity of 16 feet per second. Write a function that can be used to model the height. How long does the juggler have to catch the ball before it hits the ground? So we want the height to equal 0. We got the negative 16t squared. Our velocity is 16, so plus 16t. And then plus our starting height is 5 feet. So here's our equation. We have to factor. I see the first term's negative, which it usually is. Always will be on these. Anything else in common? No. So we'll have positive 16t squared minus 16t minus 5. We have to factor that. So we're going to do 16 times negative 5, which is negative 80. I know it's going to be a plus and a minus. They have to be 16 apart from each other. Two numbers that multiply to 80 and are 16 apart are 4 and 20. So to make them add up to negative 16, it'd be minus the 20 plus the 4. We do have to try to divide them by the number in front, 16. Both of those can be simplified. 4/16 is 1/4. 20/16, those are both divisible by 5, or by 4, sorry. So 5/4. But again, we don't need to write it in perfectly factored form. We're looking for the answers. So before we even scooch this, look, it says t plus 1/4. That means t is going to equal negative 1/4. Negative 1/4 seconds. Nah. This one is minus 5/4, which means t would equal positive 5/4, or 1.25 seconds. Is that a realistic answer? Yeah, it's positive time. That's it, man. Now, if you're a purist watching this and you're like, I would like to see it in factored form. Okay. 0 equals negative. This factored, the 4 would come to the front. 4t plus 1. And here the 4 would come to the front. It'd be 4t minus 5. It's going to come out to the same solutions. So if you want to write it all the way factored, please do. Oh my gosh, please do. Last one, a rocket is launched from ground level with an initial vertical velocity of 176 feet per second. After how many seconds will the rocket hit the ground? So we're looking for when its height is 0. We got the negative 16t squared built into the formula, and now we have this 176 feet per second velocity. It's shot from ground level, so you would have a plus 0 back there. 16 goes into 176. So we're going to factor out negative 16t, which leaves us with t minus, and then negative 16 times negative 11 gives you positive 176. So we'll get our two answers here. We got the t on the outside, that's going to be 0. The t on the inside with t minus 11 would be positive 11. Are we looking for 0 seconds? Of course not. That's when we launched it. So the 11 seconds would be the number we're looking for. It just takes some playing around with these kind of problems. You'll be all right.